A shocking new study reveals a concerning link. Exposure to air pollution during pregnancy could significantly increase a child's risk of developing autism. This groundbreaking research, born from the analysis of Ontario's extensive birth records, sheds light on the potential dangers lurking in the air we breathe. But how can something as seemingly invisible as air pollution impact the delicate development of a baby's brain? The study, published in JAMA Network Open, focuses on fine particulate matter, PM2.5, tiny particles often emitted from power plants, vehicles, and industrial processes. These particles, so small they can easily infiltrate our lungs and bloodstream, have long been linked to various health issues. The key finding? Exposure to specific components of PM2.5 during pregnancy, namely sulfate and ammonium, was associated with a significantly higher risk of autism spectrum disorder, ASD, in infants. The research indicates that the second and third trimesters of pregnancy are particularly vulnerable periods. But here's where it gets controversial. The study also found that exposure to ozone during a child's first year of life could also elevate the risk. So what's the science behind this? Researchers believe that these pollutants can disrupt fetal brain development through several mechanisms. They may trigger epigenetic changes, such as DNA methylation, which can affect gene expression. They may also cause oxidative stress and neuroinflammation, creating a hostile environment for the developing brain. Furthermore, the study points to the gut-brain axis, suggesting that alterations in the gut microbiota caused by PM exposure could contribute to neurodevelopmental disorders. And this is the part most people miss. The study highlights that sulfate and ammonium, the key culprits in this study, come from different sources. Sulfate often originates from high-sulfur fuel combustion, while ammonium is linked to fertilizer use, sewage treatment, and vehicle emissions. This means that the sources of these pollutants can vary depending on location, with urban areas often being more heavily impacted. The study also found that the association between air pollution and autism risk was more pronounced in urban areas, particularly in low-income and middle-income neighborhoods, with a higher proportion of racial minority or newcomer populations. This suggests that environmental injustice plays a role, as these communities are often disproportionately exposed to air pollutants. While the study provides valuable insights, it's important to acknowledge its limitations. The researchers estimated exposure at the neighborhood level rather than using personal monitors. Also, the study acknowledges that autism ascertainment might have missed some cases. What do you think? Does this research change your perspective on air quality and its impact on public health? Are you surprised by the specific pollutants identified or the timing of the exposure? Share your thoughts in the comments below. Let's discuss the implications of these findings and explore potential solutions together.